You think you know what big is? Our sun, a star so huge it makes up 99.8% of all the mass in our solar system, feels like a pretty good benchmark for cosmic significance. The planets, our own worlds, are just specks of dust next to it. But that whole sense of scale is a fragile illusion. What if I told you there are holes in the universe so massive they make our sun look like a single atom, 700 million light years from home? In the heart of a galaxy of giants, there's an object that doesn't just challenge our sense of scale, it shatters it. It's a place where the laws of physics are stretched to their breaking point, a cosmic titan that just doesn't fit our models of the universe. It's a monster hiding in the dark. Today, we're taking a journey to see this behemoth. We're traveling across the intergalactic void to the galaxy Holmberg 15A. And there, we'll come face to face with an object that forces us to redefine the very meaning of the word giant. Before we get there, we have to appreciate the trip itself. The distance is 700 million light years. That number is so big, it's basically meaningless to us. So let's try to put it in perspective. A single light year is the distance light zips across in a year. That's nearly 6 trillion miles. If you hopped on the fastest spacecraft humanity has ever built, it would take you tens of thousands of years just to cross 1 light year. Now, multiply that by 700 million. Our journey takes us far beyond our own Milky Way. We leave the familiar spiral arms behind and plunge into the near-perfect emptiness between galaxies. For millions of years on this simulated voyage, the view is just an oppressive, unending darkness, broken only by the faint, ghostly light of distant galaxies. Each one of those is an island universe with billions of its own stars and, more than likely, its own supermassive black hole at the center. And as we cross this cosmic ocean, we aren't just traveling through space, but through time. The light from our destination, Holmberg 15A, started its journey to us 700 million years ago. Back then on Earth, the first complex animals were just starting to show up in the oceans. The continents were in a totally alien arrangement. It was a different world. And the light from this galaxy has been traveling ever since, carrying a message from a distant past when giants roamed the universe. Finally, a new structure begins to take shape in the blackness. It's not a single galaxy, but a sprawling metropolis of them. This is the Abell 85 galaxy cluster, a collection of over 500 galaxies all bound together by gravity. Galaxy clusters are the largest structures in the universe, and they are the perfect breeding grounds for monsters. Here, gravity is king, pulling galaxies into a common center. Over billions of years, galaxies in these clusters collide and merge. Their stars and gas combine in a chaotic dance, and at the heart of it all, the supermassive black holes from each galaxy fall towards each other, eventually combining into one ever-growing beast. And right there, at the dead center of this 500 galaxy pileup, is our destination, the supergiant elliptical galaxy, Holmberg 15A. It's the biggest and brightest galaxy in the whole cluster, a bloated sphere of ancient stars far larger than our Milky Way. And it's here, in the heart of this giant, that we'll find what we came for. To really wrap our heads around the majesty of what's inside Holmberg 15A, we need a ladder of comparison. We'll start with what we know and climb, step by step, into the unbelievable. First rung, our solar system. The sun is at its heart, a star of immense power from our point of view. But on the cosmic scale, it's a nobody. So let's take our first big step up. We travel 26,000 light years to the center of our own Milky Way. Here we find Sagittarius A M87, our galaxy's supermassive black hole. It's a true giant, packing the mass of 4 million suns into a space smaller than Mercury's orbit. For years, we looked at Sagittarius A with awe. 4 million suns. It's the anchor for our entire galaxy. It felt like the upper limit of what we could imagine. But on our ladder of giants, this is just the second rung. Now, let's take another leap. 55 million light years away is the Virgo galaxy cluster, home to Messier 87, or M87. This galaxy is famous because its black hole was the first one ever directly photographed by the Event Horizon Telescope. The black hole in M87 is a beast, weighing in at a staggering 6.5 billion solar masses. It's over 1,500 times more massive than our own Sagittarius A asterisk. Its event horizon, the point of no return, would easily swallow our entire solar system. M87's black hole is a top-tier predator in the galactic jungle and was long considered one of the biggest we knew of. But our journey isn't over. We have to climb higher. Way out in the early universe, there's a quasar called TON 618. Quasars are the super bright cores of distant galaxies, powered by black holes that are eating at a furious pace. TON 618 is powered by a black hole with an estimated mass of 66 billion suns. It's an almost mythical figure from a time when the universe was young. But there's a catch. The mass of a distant quasar like TON 618 is estimated indirectly by looking at the light from the material swirling around it. It's like trying to guess the weight of a lion based only on the sound of its roar. You can get a good estimate, but you haven't actually put it on a scale. And that's what makes our final destination so special and so terrifyingly real. We're leaving the realm of indirectly guessed at Titans and returning to our target, just 700 million light years away. It's time to step onto the final rung of the ladder. We're here, the core of the supergiant galaxy, Holmberg 15A. And the center of this galaxy is weird. For a galaxy with an enormous mass of stars, its core is strangely faint and spread out. It's like something came through and kicked out all the stars, leaving behind a huge, dark, empty space almost as big as an entire satellite galaxy of our Milky Way. This eerie void was the first clue that something incredibly powerful was living here, and now we see it. The black hole at the center of Holmberg 15A. This isn't just a supermassive black hole. This is an ultramassive black hole, a title reserved for the absolute biggest, those over 10 billion solar masses. And this one has certainly earned it. Based on direct, dynamical measurements, the gold standard for weighing black holes, it contains the mass of 40 billion suns. 40 billion suns! Let that sink in for a second. That's not a guess based on how bright it is. It's a direct measurement, calculated by tracking the orbits of stars as they whip around the galaxy's core. And with that measurement, it became the most massive black hole ever discovered, using this direct method in the local universe. The comparison to our own galactic center is insane. This one object is 10,000 times more massive than Sagittarius A asterisk, the black hole that our own Milky Way orbits. It's like comparing the mass of a single person to the mass of the Great Pyramid of Giza. They're not even in the same category. Let's picture its scale. The event horizon of Sagittarius A would fit inside the orbit of Mercury. The event horizon of M87's black hole would stretch past all the planets and out into the Kuiper Belt. But the event horizon of Holmberg 15A's black hole would swallow our entire solar system without even noticing. Its boundary, its point of no return, would stretch out to a calculated distance of 790 times that between the Earth and the Sun. Our entire celestial neighborhood would just be a tiny snack for this Leviathan. This is the true scale of a cosmic monster. The sheer size of this thing is breathtaking, but its existence is also a huge scientific puzzle. It's not just big, it's too big. It's a cosmic anomaly that, according to our best models of how galaxies form, just shouldn't be there. For decades, astronomers have relied on a rule called the M-sigma relation. Basically, it says there's a predictable link between the mass of a galaxy's central bulge of stars and the mass of its black hole. Bigger bulge, bigger black hole. It suggests they grow together in a kind of choreographed dance over billions of years. Holmberg 15 shatters that rule. Its black hole is 4 to 9 times more massive than it should be for a galaxy of its size. It's like finding a mountain lion that weighs as much as a blue whale. It's so statistically unlikely that it forces us to ask if we've got the rules wrong. So how could a monster like this even form? The leading theory is a history of extreme violence. Holmberg 15A is the product of potentially dozens of galactic mergers. Imagine two huge galaxies colliding. Their stars mix together, and their two central black holes start a slow death spiral toward each other until they finally merge, sending gravitational waves shuddering across the cosmos. Now, imagine that happening again. And again, the central black hole just keeps getting bigger and bigger, feeding on its fallen rivals. This is probably how Holmberg 15's black hole got so huge. It's a cannibal, built from the corpses of other black holes. But even this doesn't fully explain its 40 billion solar mass weight. The numbers still don't quite add up. It tells us that our understanding of how these giants grow is missing a key piece of the puzzle. Holmberg 15 isn't just a curiosity, it's a silent, massive object telling us we have so much more to learn. Finding a giant like this from 700 million light years away is a masterpiece of modern astronomy. You can't see a black hole, so you have to find it by watching its gravitational pull on everything around it. The groundbreaking work was done by a team led by Kiana Schmergen at the Max Planck Institute. They used an instrument called MUSE, attached to the European Southern Observatory's very large telescope in Chile. MUSE doesn't just take a picture, it measures the light from every single pixel, allowing astronomers to map the movement of stars with incredible precision. Between 2017 and 2018, they pointed MUSE right at the faint, empty-looking core of Holmberg 15A. They were looking for one thing: speed. The faster the stars are moving, the more mass there has to be at the center holding them in orbit. And what they found were stars moving at unbelievable speeds, being whipped around by a gravitational anchor of almost impossible power. By modeling those star orbits, they could effectively weigh the thing at the center. It's the most reliable way to measure a black hole's mass, but it's incredibly difficult and had never been done for a galaxy this far away. The faint light from the stars was a huge challenge. It was a high-risk, high-reward observation. When the calculations came back, the number was hard to believe: 40 billion solar masses. It blew all the old, indirect estimates out of the water. This was proof that Holmberg 15A was home to one of the largest, most robustly measured black holes ever found. Our journey has taken us across a 700 million light-year chasm to stand before a throne of darkness. We've witnessed an object with the mass of 40 billion suns, a titan that would swallow our entire solar system. Holmberg 15A is more than a record holder. It's a monument to the scale of the cosmos. Objects like this really force you to confront your place in the universe. In the face of a 40 billion solar mass black hole, our planet, our sun, all of it just fades into near nothingness. And yet, there's a beautiful paradox here. From this same tiny, seemingly insignificant planet, a species has managed to look out across these mind-boggling distances, build instruments to weigh these cosmic monsters, and begin to understand the very laws that built them. We may be small, but our capacity to understand is vast. Holmberg 15A is a humbling presence, a reminder that the universe is far stranger and more magnificent than we can possibly imagine. It's a silent giant waiting in the dark, challenging us to keep exploring, to keep questioning, and to never stop looking up. Our journey through the cosmos doesn't stop here. If you want to keep exploring the most awe-inspiring mysteries in our universe, consider subscribing. And if you're ready for the next deep dive right now, check out our video on TON 618, the luminous quasar powered by a black hole that might be even bigger. The journey never ends.